to part one is graphing using a t-table or a chart, right? So we are going to go ahead and do a little bit of review of this. There are going to be three types of things that we're going to graph in Algebra 1. Okay, the first one is going to be a line. You'll be able to tell that it's a line when you have x to the first and y to the first. Okay, the next thing we're going to graph is a parabola. Do you guys remember what a parabola is? Have you ever seen a parabola?
No.
It's a U shape, right? So we're going to graph a U shape. Some of you guys may have seen it, some of you may not. And the last thing that we're going to graph is absolute values. Anybody know what an absolute value function looks like? Nope? Okay, so it's a V shape. Okay, so we're going to have a U shape, a V shape, and we're going to have a line. Okay? All right, so this first one I have y equals 1/2 x minus 5. What is our prediction? What do we think it is? Since x to the first and y to the first? Yeah, Peter, what do you think? Oh, you're doing the first number or something? Nope, so this is going to be a line, okay? So we're going to plug in different values, and we usually want to plug in some positive values, some negative values, and so on, okay? And we'll talk about that, especially with the absolute value in the parabola. So let's go ahead and plug in, and we'll put 0 kind of in the middle of our table. And let's do like 1 and 2, and -1 and -2. I want you to do at least 5 points. So let's do -3 as well. All right, now some of these are going to be nicer than others, so maybe I should have thought this through, and I should have chosen some better values. What do you guys think would be better than picking something like 1? Because if I do 1, I'm going to have 1/2 of 1 minus 5. Do I want to do that? No, I want to do multiples of 2. Do you guys see that? So let's do multiples of 2 instead. So let's do 4, 2, 0, -2, -4, maybe -6. All right. So when I plug in 4, and you can do it off to the side, you have 4 times 1/2, and then minus 5. 4 times 1/2 is 2, right? 2 minus 5 is what? Nope. -3, right? All right, and then I do 1/2 of 2, and then I do minus 5, so I'm plugging in the 2 now. So 1/2 of 2 is 1. 1 minus 5 is -4, right? What about 0? What do I get when I plug in 0? I'm going to start calling on you guys. Xavier, what do I get when I plug in 0? Brian, what do I get when I plug in -2? So 1/2 of -2 minus 5.
-6.
Do we see a pattern? -7, -8, right? All right, so I have 4, -3. So remember 4, -3, we go towards the positive x, and we go negative y. So I'm going to go to the right, 1, 2, 3, 4, down 1, 2, 3. That's where my point is. We're counting the spaces, not the lines. All right, if I do 2, -4, I'm going to go over 2, down 1, 2, 3, 4. 0, -5. -2, -6. See how it's kind of following in a little pattern? -4, -7. And -6, -8. Now, I didn't have to do those points. I just want to do a couple positive, a couple negative, okay? All right, and we can use a ruler if you want to, and we draw this nice straight line in. So that's our line. Easy enough? All right, so that's the first kind. The first kind is lines. But it's not always solved for y. In that case, we had y equals, so it was kind of nice for us because we could easily plug in x and we could get the values pretty quickly. So sometimes we have to get the y by itself. All right, so let's try this one. What would be good values to pick if I had -3/4?
Something with the
Multiples of 4, right? So I want to pick things like 8, 4, 0.
12.
Yeah, so let's do 12, 8, 4, 0, -4, and -8. Does that work? All multiples of 4? Yeah. All right, and it's a little bit harder. So some of you guys that have the fraction phobia like we've talked about are not going to like these. Okay. So if I do -3/4, and I'm multiplying by 12, and then I'm adding 2. Okay, so remember when we do -3/4 times 12, you can think of it as 12 over 1. You could just multiply across the top and multiply across the bottom and reduce. You'd have -36 over 4. -36 over 4 is -9, and then adding the 2, what do we get? -7, exactly. And if this is a line, there's probably going to be a pattern, so hopefully we'll see the pattern after a couple. All right, now if I plug in 8, so if I do -3/4 and I multiply by 8, I get -24 over 4 is -6, added to 2. What do I get? -4, right? How about 4? Can you guys do it in your head? -3/4 of 4. -1, add a 2. Wait, negative 3/4 of 4? Is that negative 1? Negative 3/4 of 4, I think you're getting the answer, right? Is negative 3. Negative 3 plus 2 is negative 1, right? You guys got it. All right, so do we see the pattern? Yeah. So each time we add or subtract 4, we are adding 3. All right, so we're subtracting 4, subtracting 4, subtracting 4. So as long as we follow that pattern for the x's, the pattern for the y's is going to follow as well. All right, so I'm going to get negative 1 plus 3 is going to be 2. 2 plus 3 is 5. 5 plus 3 is 8. And we draw it in. All right, Ryan, take some notes, write some stuff down. All right, so I get 12, negative 7. 12 is off my chart, so I'm not going to graph that one. How about 8, negative 4? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. It's right here. 4, negative 1. 0, comma 2. So go over 0, up 2. Negative 4, comma 5. And negative 8, comma 8. All right, so there's our line. And graph it in. All right, we feeling pretty good about graphing lines? Now we're going to be doing a lot of graphing lines in Algebra 1, so we're going to learn other methods. Do some of you guys kind of know the method? So like if I had y equals negative 3/4 x plus 2, have you guys seen y equals mx plus b? Yeah, so that's kind of what we're getting towards. B is going to be what we call the y-intercept. It's where it crosses the y-axis. So which one's the y-axis, the horizontal one or the vertical one? The vertical one, the y-axis. And where does it cross? It crosses right here at 2. And then the m is what we call our slope. So it's our keys. Our slope, in this case, is negative 3/4. So has anybody seen this? What does this mean? Nope, you haven't seen it? Well, we're going to see it in this chapter. So it means you go down from that first starting point. Our starting point was the y-intercept. We go down 1, 2, 3, and we go over 1, 2, 3, 4 to get the next point. And then we always go down 1, 2, 3, and over 1, 2, 3, 4 to get the next point. Does it make sense? Yeah, Peter?
So M is where the intersect is?
B is where the y-intercept is. So B is where you start along the y-axis.
So
And then from there you get another point. What about what?
So M is where x crosses y?
Okay, so let's look at that last one we did. So we had y equals 1/2 x minus 5. So negative 5 would be our y-intercept. So we go down 1, 2, 3, 4, 5 to start. So we're at the y-intercept, and we have a slope of 1/2. 1/2 is a positive number, so as I read it like a book, left to right, I go up. And I'm going to go up 1 over 2. We call it rise over run. So we would go up 1 unit over 1, 2 units to get the next one. Do you guys see it? So we'll be doing that in a couple sections. The negative 5 is the y-intercept. Yep, exactly. So we'll be doing a lot of that. But if you guys kind of know that, you can check your answers, right? So you can say, oh, wait, my t-table is definitely right because I know my y-intercept and I know my next point. All right, so this one is not solved for y, but it was kind of nice when it was solved for y because we always, whenever we plugged the x in, we got the output was whatever we were graphing, right? So we're going to isolate the y. So when I say this in class, I'm never going to say isolate the y value. I'll say solve for y. So if you hear me say solve for y, you'll know what that means. So if I have 2x minus 3y equals 12, and I want to get the y all by itself, what do I have to do first to both sides? Any ideas? You could add 3y, but I'm trying to get it by itself, so let's get rid of the thing next to it. Let's get rid of this negative 2x, or this 2x. So subtract the 2x over. Now, can I combine these two things? 12 minus 2x? No, those are not like terms, right? We've talked about that. So we have to leave them separate.
There are no like terms.
So it's 12 minus 2x. And I have my negative 3y. Now how do I get the y by itself? How do I get rid of what it's attached to? Divide by the negative 3, right? Not add 3. Do you guys see why it's divide? Because it's negative 3 times 1.
Yeah, because you just moving the y and you add it.
All right, so when we do this, we get y equals, and this negative 3 actually goes into both pieces here. So if I do 12 divided by negative 3, it's kind of like if I had a negative 1/3 outside of parentheses. It goes into both things, right? Same idea. So what's 12 divided by negative 3? Negative 4. What about negative 2x divided by negative 3? Sarkis, pay attention. Right? I'm going to get plus 2/3 x. So really the way that we normally write this as a line is 2/3 x minus 4 because it goes back to that mx plus b thing. Okay? So eventually we're going to get to the point where we don't have to do this t-table, where we can graph it without doing the t-table. So some of you guys might be there already. Where would I start? Where's my y-intercept? At negative 4, right? I would start down at 1, 2, 3, 4. And then from that point, I would go 2/3. I would go up 2 over 3 to get the slope. So if I go up 2 over 3, my next point would be right there. Okay, does that make sense? And then you can make a line just using 2 points. But you have to make sure that it's a line. So some of these things that we're going to do are going to be absolute value graphs or parabolas. And then you wouldn't be able to graph it with only 2 points, right? So be careful. Look for your x to the first, y to the first. All right, so what are numbers that we would pick if we had y equals 2/3 x minus 4? What multiples of what?
3.
3. So let's do 9, 6, 0. Well, let's do 3. Whoops, 9, 6, 3, 0, negative 3, negative 6, right? You want to start with 0? 0 is the easy one. What do we get when we plug in 0?
4.
Negative 4, right? All right, I'm going to call on you guys. Max, what about when I plug in 3? What do I get? 2/3 times 3. No? Close. 2 minus 4. Negative 2, right? What if I plug in 6, Colin? 2/3 times 6 minus 4. What's 2/3 of 6? 2/3 of 6. 4, and then minus 4. 4 minus 4 is 0, right? Do we see the pattern? So each time that I'm subtracting 3 from the x's, what am I adding for the y's? Or subtracting, I guess. Subtracting 2, right? Do you think those numbers have anything to do with the slope? Yeah. All right, so my other numbers, I'm going to have 2, 0, negative 2, negative 4, negative 6, negative 8. And you can graph them, and you will see that they are on this line that we started. Okay, so we have 9, 2. There's 10 spaces, if that helps. So 9, 2 is right there. 6, 0, 3, 4, 5, 6. 3, negative 2, which we already had. 0, negative 4. Negative 3, negative 6. And negative 6, negative 8. And then we can graph our line in. Okay, we good with lines? You guys can do that on your homework? Okay, so let's do some other ones. So let's do the next one, absolute values. So what shape did I say an absolute value would be?
U.
No, not a U, it's a V, all right? So it's going to be a V shape. So every single time you see an absolute value in the problem, we know that it's going to be a V shape, okay? So as we graph this, so as we use our t-table, we definitely want to pick positives and negatives. All right, and the number that I put in the very center, or towards the middle, I guess I didn't give you a nice even number of spaces, did I? Or a nice odd number, I guess, of spaces. I gave you an even number. The number I want to put in the very center is what makes this as small as possible. So some of you guys are smart enough to figure this out. What's the smallest that you can get out with an absolute value? 0, right? You can't get negatives out. So what am I going to plug in for x to make this as small as possible? Are you guys all smart enough? You got this figured out? Xavier, what do you think? 2. Yeah, oh, you got this. So see if I plug in a 2 for x, 2 minus 2 gives me the 0 that I want. Okay, so 2, if you guys are sneaky and you're good at this, you'll put that in the middle of your t-table. So I'm actually going to do another little, we'll put it in the very center. So we'll put 2 right here in the middle. Okay. So that's going to be in the middle. So I want numbers before that and numbers after it. So it doesn't matter what order. If you start with the bigger numbers and go to the smaller numbers, it doesn't matter. Let's go backwards. So let's do negative 1, 0, 1, 2, 3, 4, and 5. So we have a lot of points. But these ones are pretty speedy. So let's start with the one in the middle, with the 2. What did I get when I plugged in 2? 0. Okay. If you put that in the middle, and you're picking numbers that are above and below it, like we did in order, then you're going to have a lot of symmetry in your table. So let's think about it. If I plug in 3, so if I have the absolute value of 3 minus 2, what do I get? 1, right? 3 minus 2 is 1. Absolute value of 1 is 1. What if I plug in 1? 1 minus 2 in absolute values gives me the absolute value of negative 1, which is also 1. So see what I mean by the symmetry? You'll get 1 and 1 there. What about if you plug in 4 or if you plug in 0? What do you get when you plug in 4? 2, right? What do you get when you plug in 0? Negative 2 in absolute values is 2. See how it works? And what do we get when we plug in 5? 3 and 3. All right, so I'm going to have negative 1. So go back 1, left 1, up 3, 1, 2, 3. I'm going to have 0, comma 2. I'm going to have 1, comma 1. I'm going to have 2, comma 0, so I don't see the V shape yet. But now when I do 3, comma 1, do you guys see where it starts? 4, comma 2, 5, comma 3. And we know it's a V, so it's a sharp V, not a U. It's like that. Good? Easy enough? So yeah, you can make it really easy on yourself if you put the number, the smallest thing possible in the middle, because that's going to be like your vertex, right? We call that the vertex, the tip. All right, so how about this one? What makes the absolute value part as small as possible? 0, right? So let's put it in the middle. So let's do negative 1, negative 2, and negative 3 above it, and let's do 1, 2, and 3 below it. All right. Now that 3 is not an absolute value, so we're only going to do the absolute value part, find that answer, and then we're going to tack on the plus 3. Okay? So the absolute value of 0 is 0. Plus 3 is 3. Absolute value of 1, Will. Ryan, stop. Write some notes. Absolute value of 1 is 1. Plus 3 is 4. What about negative 1? Absolute value of negative 1 is 1. Plus 3 is 4. So see why we put that in the middle? It makes it a lot easier if you do that. Because once you get 1 point, you're getting 2 points then. All right, how about 2? What do I get? 5. Same thing with negative 2. And 6 and 6, right? So we're going to get negative 3, comma 6. 1, 2, 3, 4, 5, 6. Negative 2, comma 5. Negative 1, comma 4. 0, comma 3. 1, comma 4, so that's where it goes back up. 2, comma 5. And 3, comma 6. All right. Easy enough? All right, the next one's a hard one. If you can get the next one, you get all of them. What makes the absolute value part as small as possible? What should I plug in? Not 0, because 0 will make it 2. We want to make this absolute value part equal to 0. Not negative 1. Negative 2, right? If we put that in the middle of our table, we're good. So I'm going to put negative 2 in the middle. All right, so it's a little bit harder. So let's write it out. So I have 3 minus absolute value of negative 2 plus 2. So that's going to be 3 minus absolute value of 0, which is 0. So 3 minus 0 is 3. And I want to pick things that are smaller than negative 2 and bigger than negative 2. So I'm going to do the negative 1. Sorry, let's do negative 3 actually, since I've been doing the smaller ones. Negative 3, negative 4, negative 5, and then negative 1, 0, and 1. All right, so how about when I plug in a negative 3? So off to the side, 3 minus absolute value of negative 3 plus 2. What is negative 3 plus 2?
1.
So it's negative 1, but then in absolute values you're saying it's 1? Yep,
Yes.
3 minus 1 is 2. So that should be the same as if I plugged in negative 1. So as long as you're putting that in the middle, you'll get 2 points every time you do that. How about when I plug in 0? What do I get when I plug in 0 here? 0 plus 2 is 2. Absolute value of 2 is 2. 3 minus 2 is 1. Lots of things we're doing. How about negative 4? Is that the same thing?
Yeah.
Because negative 4 plus 2 is negative 2, but in absolute values it's 2, right? So 3 minus 2 is 1. So it's the same thing. And then what about 1? 0, and 0. All right, now this is a weird one. So as we sketch it out, I get negative 5, 0, 2, 3, 4, 5. I have negative 4, comma 1. I have negative 3, comma 2. Negative 2, comma 3. Negative 1, comma 2. What's happening here? 0, comma 1. 1, comma 0. It's an upside down V, exactly. What do you think made this one upside down? What's different about this than the ones before? Any ideas? What makes this different?
There's the negative before
Yep,
the
it's the negative, exactly. When there's a negative in front of that absolute value, it flips it over. So if you see a negative in front of an absolute value, it's going to be upside down. Exactly. Okay? All right, so how about the absolute or the parabola one? So these are going to be U-shaped. So this is the last type that we're going to graph. This is kind of a long section, so I've broken it into 2 parts. All right, so a parabola is going to be U-shaped. Now it's not like a perfect U. It's kind of like it goes like out like this, okay? So don't draw like the letter U. It's more like a curved V, that kind of view. All right, so you can recognize that you have a parabola when you have an x squared. So if you see an x squared in your problem, we are going to have parabolas, okay, in Algebra 1. All right, it doesn't mean every single equation has x squared. Like if you had x squared and y squared, it's actually a circle. But right now in Algebra 1, when we see an x squared, it's going to be a parabola. All right, so I want you to think exactly like we did with the absolute value. What makes the part that's being squared as small as possible? 0, right? If I plug in a negative number squared, negative 1, and I square it, what is negative 1 times negative 1? It's positive, right? Positive 1. So let's put 0 in the middle. It's fine if I don't do all of them. All right, so let's do numbers bigger than it, and let's do numbers that are smaller than it. You can add another one if you want to. I didn't realize I was giving you an odd or an even number of spaces. I should have done an odd number.
2's not negative on the top.
Yes, thank you. I'm sure I would have caught that, but I'll give you a bonus point. All right, so if I'm going to square things, so what is negative 2 times negative 2? Come on, you guys know this. 4, right? All right, Caitlin, what about negative 1 times negative 1? No. 1, right? Negative 1 times negative 1 is 1. All right, Will, 0 times 0. 0. 1 times 1. 1. 2 times 2. 4. 3 times 3. 9. So we're going to have 0, 0. We're going to have 1, 1. We're going to have negative 1 and 1. So negative 1, 1. So it looks kind of like those V shapes that we had before, but we know it's a U. Negative 2, comma 4. 2, comma 4. And 3, comma 9. What would I get if I plugged in negative 3? Negative 3, comma 9, right? Do we see the U shape? Why are you trying these? It's going to look like this. All right, so that's a parabola. All right, that's the most basic parabola. We call that the parent function. A parent is the most basic form of a graph. Okay? All right, so let's look at the next one. So if I have x plus 3 in parentheses squared minus 1, okay, it goes back to the absolute value. If that had been an absolute value of x plus 3, what would we plug in for x to make it as small as possible? Yep. You guys remember?
0.
Not 0.
Negative 3.
Negative 3. We want to undo that 3, right? We want to make it as small as possible. So we're going to start out with negative 3. I'll extend this one. So we want numbers above and numbers below. Whoops. So let's do negative 4, negative 5, negative 6, and let's do negative 2, negative 1, and 0. So you don't have to do things this way. It just helps to get that, like, the U shape. If you just pick random numbers, like if you pick 1, 2, 3, 4, 5, 6, maybe you don't see where it curves around, right? So this will be a good kind of guide to get the U shape in there. All right, so negative 3. So Xavier, what do I get when I plug in negative 3? So I'm going to do negative 3 plus 3. I'm going to square it, and then I'm going to subtract 1. What did you say, Xavier? Negative 1, exactly. All right, so Peter, how about this one? Negative 2 added to 3. I'm going to square it, and then I'm going to subtract 1.
So it would be negative 2 plus 3 would be negative 5. So it would be
Nope, negative 2 plus 3 is positive 1.
Positive 1.
Square it.
So 1.
Minus 1.
Minus 0.
0. So that ends up being the same if I plugged in negative 4 or if I plugged in negative 2. They're the same. All right, how about negative 1? So Maya, negative 1 plus 3. 2. 2 squared is?
4.
Minus 1? 3. So these both are going to be 3. And then 0, Isabella, how about you? So 0 plus 3 squared?
6.
Oh, nope, 3 times 3 is 9. And then minus 1? 8. So we get 8 and 8. All right, and then we plot all those points. So we're going to have negative 3, comma, negative 1. We're going to have negative 2, comma, 0. We're going to have negative 1, comma, 3. So left 1, up 3. 0, comma, 8. So we're way up there. There's 10 total in the grid, so we're going to have 2 less than where we were. The top, I mean. Negative 4, comma, 0. Negative 5, comma, 3. Do you see where it curves back around? And negative 6, comma, 8. Okay. So sometimes when you're graphing these, maybe you mess one of them up. And then all of a sudden you have one that's like down here. You guys know the shape, though. You're going to be smarter than that, right? You're going to say, oh, wait, I know that it should be a U shape. That point is probably one that's incorrect, and check that point. So if you have a single point that's kind of off, check that point. I know you guys are all thinking that this is super easy right now, but when you get to your homework, you're going to make mistakes. It happens every year. So don't panic if you're making a mistake. Just check your values again. All right, so let's do this next one. This is the last one. So 2 minus x squared. So let's plug in 0 in the middle. So 0 squared. So I'm going to have 2 minus 0 squared. So 2 minus 0 is going to be 2. All right, here's the hard part. 2 minus 1 squared. Do the squared part first, right? Don't do negative 1 times negative 1. 1 squared is 1. 2 minus 1 is
1.
1. Now, do you see that that's the same as if I plugged in negative 1? Because when I plug in a negative 1 and I square it, I put it in parentheses. Negative 1 times negative 1 is 1. 2 minus 1 is 1. So I still get a 1 there. And if we knew that this was the center one, we would be good. We would know that. How about 2? When I plug in 2, 2 minus 4 is negative 2. 3. 2 minus 9 is negative 7. So I'm going to plot those points. So I have negative 2, negative 2, negative 1, 1, 0, 2, 1, 1. Do we see where it's going? 2, negative 2. So this is a downwards one. What made it downwards? Yeah, the fact that it was a negative of the x squared, right? So if you see a negative x squared or a negative absolute value, that flips it around. All right, we'll stop there.